Hello everyone. This video is to describe examples about data flow and how to deploy some processing over it on Google Cloud platform in both streaming and batching mode. Let's start with our first example, which is word count. In your repo, you found two folders. One of them is word count, and within word count there are two files. One named word count.txt, and in word count.txt there are the instructions and commands that we will use in this tutorial. So if you want any of them, just copy and paste. And for the first line, this is the link in which this tutorial is taken from. It is not copied from this link. We were much flexible in preparing this material, so some of the steps in this link is skipped, some updated, and some changed at all. But this is the source, and let's start. First, I created a new project. You don't need to do this. I did this because I want everything to return to its default value, but you don't need to do this. Continue in your previous project, currently working project. And the first step here is to enable Dataflow API. So let's go to our project here and search for Dataflow API and go to it and just enable it. It will take some minutes to be enabled. In this minutes, let's speak about the next step. The next step is to create what is called service account. So let's go to this our search and search for services account. Service accounts. Okay, what is service account? It's like a user to this project, and this user has some permissions, which here is called rules, and these rules are like a list of what this user can do and what can't do. To work and to deploy a pipeline processing over Dataflow, you must have a service account. For now, any rule will work with us. It doesn't matter what is the rule, but in future we will update these rules. So just let's start and create a new service account. And for this service account name, because it is global and we don't want it to be repeated, just I'll copy the project ID. I put it right here and embed it with hyphen SA for service account and create and continue. What is the rule? What is the permission you want to give to this service account? Anyone like a compute engine service agent. If you didn't find it, you can search here just compute service compute engine service agent like this. So just that I'll add this rule and I can do I can press continue or just done and finish it. Okay, now I have created a service account so I can use Dataflow. And to use Dataflow, you should have a default of Python 3. So let's check the Python version. You'll find that the Python version, the default one is Python 2. There is like notifications that it will be soon changed to Python 3, but if it is Python 2 like this, you should change it to Python 3 yourself. The good news is that Python 3 is already installed. You just search about the Python 3 version, you will find this is Python 3. So, um, how to make Python 2 the default? There are many ways, but the easiest one of them is to create virtual environment. So let's create virtual environment. To create it, just I create it using Python 3, not just Python, because I want it to be in Python 3, and then hyphen m, and the command is virtual environment, and then give it whatever name you want, like env for environment. So this is command will create a virtual environment called env at the home directory, because I am at the home directory right now, and it will be in Python 3, because Python 3 is a command used to create this virtual account, a virtual environment. So let's press enter. Now it is created. If you just list all the folder and files in the home directory, find a new created folder called env, the same name as the environment. And in this folder, all the metadata libraries for the environment will be installed. So to enable this environment, just write source and home directory environment, then activate. Now we are working inside our environment, and you'll find the environment name written like here. And if you wanted to exit this environment and return to the default one, just try to deactivate. And when you write deactivate, the name is disappeared from the beginning before the prompt. So let's return to our environment, and let's check for the default Python version. It should be Python 3. This is 3.9. It's okay. Yes, that is another condition to use Dataflow over GCP, just to have a default of Python 3. Now let's install the library that is used for Dataflow, which is Apache Beam. But before it, let's update the pip command. So pip install pip upgrade. This command will try to upgrade pip command like this. Now it is upgraded. Let's go and install the library used for Dataflow, which is called Apache Beam, which is a one customized for GCP, for Google Cloud Platform. So let's install it. Okay, here is a lot of libraries get downloaded and installed, and also a lot of examples. One of these examples is word count, and that is the example that we'll try um, to run and to update and to understand. So now it is installed. It's okay. Let's run this example. Let's start first by how we can run it. So just Python hyphen m. Of course, this all inside is in virtual environment. Outside virtual environment, we cannot do this. So Python hyphen m, and then um, within Apache Beam, there is a folder called examples, and within examples there is a word count. Another argument needed for this example to run is an argument which is output, which specifies the output file, which is the output of this code, which is the frequent how frequent each word is repeated in a given document will be stored. So let's store it in a file called outputs like this. Now let's run it. He asked me for authorization, so authorizes the operation, and now it will run. we will try to understand all these, but these are log information showing which worker is running and which job is done, and if there is an error, it will appear here. But now it's okay. It is finished in zero point 0.1 second, and um, there is no failure, so it's okay. So let's get a list of all files and folder, and we will find a new file called outputs 0 of 1. Of 1 means that the output is stored in one file. If the size of this file is huge, it may be stored in multi-files. So maybe like output 0 of 4, 1 of 4, 2 of 4, 3 of 4. And this is the index of the output. This is the first file of a total of one file. So let's try to display what is in this file, like more outputs 0 of 1, and here is the result. In this document is Shakespeare famous book. It's called King Lear. And in this book, the word king has been repeated 243 times, and on Solir you can see whatever you want, each word with the count of it. How this is generated, we can check this. We will check this in the future, but just for now, how to run it. So as you can see now, let's click like Q to exit more, and here we run the file, and this file is written is example of Dataflow written in Apache Beam format, and here is how we run it, just as a normal Python file. But this file has run over our local console or shell display here. It didn't run over the cloud. So let us run it over the cloud. Our goal is to run it globally, not over a local machine. Um, but we got some problems, like where is to store the output? We are storing the output because this command is connected to this shell, so the output will be stored in this shell. If we are working over cloud, we need like a global address, a global path to store this information on. And this global path or address is called bucket, and it is created over what is called cloud storage. So let's go and create a cloud storage. So go for search and check for cloud storage. And in cloud storage, we can create a bucket like this. Well, let's call it the same like the project ID and append it with gs. And where is this bucket needed to be? And click continue. Then it choose where to store this data, maybe in multi-region, and be in one region like in North America, Northeast, which is Toronto, and then create. Okay. How to access this bucket? You can access this bucket using a path. It is written like gs colon / and then the bucket name. This is the path. That is how you are saying that you are you will, this is a pass to a bucket to a cloud storage over Google Cloud. So it is Google Storage with this name, and this name is globally. So it shouldn't be the same as any other bucket in any other project. So that is the reason that I use the project ID as a prefix to it. And whatever you will write here, write it. So this will make it is difficult to be repeated. So it's okay. Now we did this. Let's store something as a variable in our shell, like store the project ID as a variable because we will need it in future. So instead of writing the whole ID, just write the variable, and it's okay, like echo dollar sign project. And here is how you are saying that you wanted to display the value of this variable by writing dollar sign and the name of the variable, and here is the value. And also, let's, for our bucket, write it like this. Bucket will be gs colon slash slash, and gs. And here is the bucket address, and of course you can echo it by just like this. Okay, this is a brief way to write our project ID and our storage path. So why we need this? We need this because if we want to run this command, which is word count over the cloud, we need to add other arguments more than the output. Here is the output argument. We used this before, but now it will be linked to our bucket. But also we need to provide it with a region, which is, this will be run, which is North America, Northeast 2, which is Toronto, and also for a runner. We want to run this over the cloud data flow, which is Dataflow runner. Providing this argument means that we will need this example to run over cloud, not locally. And to run it over cloud, we need to provide the project ID and also a temporary location in which some um, of the steps can be, or the temporary steps can be stored. So let's take this and let's write it. So let's go open this and here. So now let's go and run Python -m Apache Beam example word count, but we'll start by giving our project like project, and instead of writing the whole project, just dollar sign project. We'll get it from the shell variable, and also we need to provide it with the region. So the region will be North America, Northeast 2, like this. This hyphen hyphen, and also we need a runner to be Dataflow runner. Okay, and temporary location. Of course, you can copy it from here. Just I'm writing them with you to get familiar with them and understand each parameter. So for table location, it will be inside our bucket, and maybe in a path in a folder called temp, whatever the name. You can name it whatever you want. And also our output will be stored in our bucket in a folder called result in files starting with a prefix outputs. Okay, let's run it. So this is a problem here. Yeah, bucket is all uppercase. So what is the problem? Project. Okay. So it's this project. Now run it. Okay. Here, everything we have written is correct, but this problem is start to appear weeks ago because Python has upgraded Python inside the shell is upgraded automatically to 3.9 instead of 3.8. So to run any of the codes that you can find over internet, you just need to add a new argument, which is experiment use unsupport Python version. So just this argument needed to be added at the end to run it over 3.9 Python version. So let's run it right now. Okay, it will take times. As you have seen in previous videos, let's first go to Dataflow jobs. There is a worker like a machine in or maybe container that is deployed, and in this worker it can be scaled to 1 2 3 according to the payload, the load over this worker, and also each step in the processing. The processing is like a pipeline which consists of steps. Each step feeds the next one, and these jobs can be run. So if you open what is data flow jobs as we did, we'll find one is started. This is a new one here. If you enter it, you will see the pipeline for this example. We will go and read this example, but right now we will learn how to run it. So you will see this. The first stage is like read, and then which reads a file, and this file is King Lear, a famous Shakespeare book. And then after running this stage and read the file, it go to other stage which is split, on which each line is split into word, and there pair was one which convert a word to uh, tuple, which is the key is a word and the value is one, and then grouping them and sum. So for each word, the keys will be grouped and the value will be summed, and then the format is adjusted, and then it is written. So this is our stages. You choose any of these jobs, like here, you can see some statistic. It takes time to run, so it started is starting. Right now it doesn't work right now. So there are here two stages in read. You can open them like here. There are two stages, and here is the status of these stages. Also, if you are choosing this job and go to show, you can see like logs of this job here. If there is an error, if there is some warning, you can read them from here. It doesn't started yet, so when it starts, there will start some message to appear here. But if you just clear selection, you will see like log statements for the whole pipeline. And if you choose one job, this will be changed to the job only. Okay, it will take time to work because there are virtual machines and there are image deployed on it, and within this image there are code that is started to run, and for this code to run, some libraries has to be installed, so it takes minutes to start, and when it starts it work in a fast way because it is work over cloud, and the result will be output immediately. So let's wait a little. And also in your console, you see like some log data like here. But just let's wait until it works. Okay, until it works, let us speak what is Dataflow and what is Apache Beam. Apache Beam is a library that is used to just describe this pipeline. You wanted to you wanted to do this pipeline, which is read. So you wanted to describe that you have a job of reading from a file and a job of splitting. So how you are describing this? You are using Apache Beam. So waiting it to run. And of course, this is difficult. If there is a problem, it would be difficult to locate this problem. So try to read the logs because the logs here will say to you where it fails and why. So try to get familiar with the logs here because you cannot log into these machines over cloud and uh, read or debug the code there. So still waiting. So a new okay, it's run now. There are new commands. This is one of two stages finish here. Okay, let's close this right now. And this is stage finish, this stage finish, all of them finished, still working here. So as you can see, each stage feeds data to the next stage, and the next stage fed to the next, and so on until all of them are finished. Now it is in the right phase, and it finished successfully. So if you go back right here, you find that this processing, which is batch, it is still running. It is now in the closing phase. So if you go to here, go to your shell here, you'll find that it is in the phase which will stop the workers, and when the status will be changed from running to maybe end successfully or something like this. So that is how you can run your example over the cloud. Again, how we do this? We have choose runner, Dataflow runner, and to do this, we have to provide it with another with other argument like region, project, temporary location, and also experiment like here. So let's check for our result. Our result must be stored in this returns to us a command. Our result will be stored in bucket result outputs. So let's go to our cloud storage, and this is our bucket. Go to it. You will find that some there are some folders created, which is temp for temporary and result, and within result there are three files. It is like a huge, more than the one in the local, but there are three files. You enter any of them, or just download whatever you want, like download and see the values in them, or you can copy the path until it finish and clean up. Let's open a new terminal like here and use what is called gsutil, which is command using to access GS Google storage, and list all the files within result. Okay, gs colon slash slash like this, and you can see the values within any of them, like taking this as a copy and gsutil more. Okay, there is no more, maybe there is cat. And you can see here is each word and its count, how many it is being written in this document. So that is okay. We have done this and run the code, but we didn't see the code yet. So if you remember, let's go to the version that locally runs. The code we are run is inside Apache Beam, inside a folder called examples, in a file called word count. But where is the exact path of this file? We cannot know. So let's take the word count as a copy and search it. So let's search for it, like find and search within our environment, because every library is installed inside our environment, and search by name of word count asterisk. So just it is one hyphen here, Okay, this is a lot, so let's instead of asterisk, let's word count.py. And there are two files. One of them is inside Apache Beam, inside examples, and it's called word count. So let's copy this file into our home directory. So that is our home directory. Now we will use command which is copy cp, and that is a source which is this path that I have copied, and put it, the destination will be inside our home directory, and we'll call word count.py. Now if you search, you'll find a new file which is word count.py is created here. You can open it whatever you want or using the editor. So let's start opening it with our editor. Let's open another here, another tab here, console, and choose open editor. So if it is disconnected, you just need to return to the same virtual environment, because when it is reset, everything return to the default. So let's return it to the environment, the virtual one, which is environment then, and also activate. And also all the shell variables are deleted, so you need to again copy the project ID and put it inside the project, the bucket, and put it inside bucket, and so on. So here's how we return it to our virtual environment, and here is our editor. Let's go to word count.py. And we try to understand, let's try to understand what is written here. The first is called argument parser, which parses the arguments. And what is this arguments? That is what you are writing here. Uh, where is it? It will come. Yeah, like this. This is arguments. And to parse it, there is a built-in library that parse it for you. Just you need to provide it with the name of the argument, and will give you the value. So just here we see that we have two arguments can be added. There is a default arguments which is default for data flow, and extra argument, and there are the extra ones. And for this extra argument, there is one will start with hyphen hyphen input, and its destination will call the input, and has a default value, which means that it can be skipped, can be maybe not written. It is optional, and if it is not given, this is will be the default value. So if we didn't provide it with an input, it will be King Lear.text instead of inside Shakespeare inside this bus. And this is a Google storage bus. And here is some hint when this variable is missed, what to be printed to the user. And also there is another argument which is output, and its destination will be output, and it is required, it is not optional, and has a default value. And here is what would be printed to the user if it is not written. So we have two arguments, one optional and one is necessary. And we can add whatever we want, like we can add a new argument, like going here and just copy and paste, maybe it's called output 2, and this shall be output 2, and this is optional. Maybe we have a default value of outputs to something like this. I don't know what is, and then we can the help is another output file to write other results to something like this. So now we just you are configure the parser, and then you are running the parser, and all these value will be set within what is known arguments. So there will be inside known arguments dot input, which is the value of the argument, the input argument, and known arguments dot output, and known arguments dot output two. So there is what is value we have. So we can do whatever we want. Add arguments as you wish. So now let's go. After this, we will start by writing description of the processing steps, the jobs. So the first job will be that is the default one that we started with. This is our start, and first first job will be we will pipeline this to a new job, and this new job will called read. For read, it will call a function which is read from text. Read from text is a built-in function within Team, and here it is included from here, that reads line by line from this text, and the output of this pipeline will be like a list, a collection of lines, and this pipeline is called, we call it lines. Um, Note that we are not speaking about a code, we are describing a code. We are describing what the processing will be. We are not doing the processing here. So lines here is this steps, this two steps, or just it is one because this is a dummy one. This is a start and it is dummy. And we can add to it a new jobs, a new steps. Like piping out after this pipeline, we will take the data output from uh, this stage and apply it into a new one, and we call this split. And for a split, we will convert each line, or we can split each line into a list of words. So the lines here we converted to word. And how can we do this? We can do this by applying a function called, or like a class here is called word extraction do function. And here is word extraction do function, which inherited from beam do function, and have a function called the process, and within this process it will take an element from a previous stage, from a previous job, and do some process over it and produce a new element. So here is the code, and how this is done. It is done by splitting each line by the white spaces and with comma. Okay, so here is how this is done, and the output will be output as a string. The next step is to provide the output of this stage to a new stage, which is called pair with one. And pair with one will take each word, and as an x here, this is called lambda function, and lambda function will it is a nameless function that takes an argument of x and return this. This is map, and this what you see in the map reduce example. Here the word will be converted into uh, tuple of the word as a key and one as a value. And then we'll start to reduce by shuffling at first, and to do this we will combine by key, and do reducing by summing the values. So for each key, we will summing the values. So for each word, like king, we will group all kings and sum the values, which is 1. So we are summing the ones to have the count of how many king has appeared as a text, and the output will still be tuple like king 15 or king 100, whatever the frequent in which the word king has appeared in the document. So still it is tuple here. Again, this can be converted uh, like using a map tuple function. Uh, um, you can note that map whenever you are using map, it is one-to-one function, which means it takes one element from previous uh, jobs and do some conversion on it and produce just one element. So it is take one element and produce one element. So if it takes 100 element, it will produce 100 transformed element. It is not like reduce or combine bar key. Here we are take a list and produce an element from this list. So like take 100 king and produce just king and 100 as one element. So that is the three jobs here, and these three jobs we call them counts. Then we can take count and append a new job, and this job will call format. And for this format, it will call map tuple, and for this it will apply a function called format result, and that is the function format result. And for this function, it will take for each tuple, which is the first element in this tuple is the word, and the next is count. It will convert it into a string in this format. Uh, and percentage s it will be replaced with the value of the word, and percentage d will be replaced with count, and s for string, and d for integer or for decimal. So this will be a string here. So when you are applying uh, this job to the sum, this sum will be converted into a string, and then take this output and apply it to a new um, job, a new step, which write to text. So each of them will be written in a line in a text file, and the text file path will be provided by non-arguments.output, which is like this outputs, which is provided with the argument optional output in the command line. So if you can see, the input will given by the user as argument, and the output will given by the user as argument. And here is the code. And if you return to like let's open a new tab like here and go to the data flow jobs. The names here is the same as written in the code. Like the first job is called read or read, which is this. The second is split, which is this. The third is pair with one, which is this. Then group and sum, which is the fourth one right here. And after this will be format and then write. So there is format and write. So each job of this you are describing here and give it a name, and this name will be used in this graph. Okay, now let's try to write our own code. So to do this, let's go and uh, copy word count, which is inside the home directory, dot py to home directory word count 2.py. Here we'll create a new one, and this will be a copy of the word count into word count 2, and instead inside of word count 2 we can update our whatever we want. Um, One technique to debug this code is just to take the output of a given stage and print it. Like uh, if you want to know what is the output of this stage, so let's here is the opening of brackets, and here is the end of this bracket. So let's end it right here, and let it like call this like a temp, and will be counts here, which is temp, and then appended with this. So just I divided it into two um, uh, pipelines, temp and counts, and temp has these two jobs, and then the pipeline count will continue adding the third, and then output will use counts and add a fourth, and so on. Why I did this? Because I can go here and add a new one, like printing. Let's call it printing, and for this it will have a one-to-one function, which is beam.map, and for the beam.map, just for each value I wanted to print this value. Okay, so if just we save this and go to our console, and then run it again. Let's run it locally, because locally it takes a less time in the starting. So let's go and run it locally, right, like here, but instead of this it will be word count 2.py, and will be instead inside our home directory. So just delete all this. It will be like this. So there's a warning, if there's an error, there is an extra bracket here. Now go and run it. So what you can see here is output with this stage is printed. So for each word, it will have a 1 as a value, and then it will be printed like here. And after this, it will be grouped. So if you wanted to see it grouped, just can copy this and paste it like here, and go for certain it as it was, like here. So there is counts here, and just the output of all this, which is after we are combining by the key, which is a word, and summing the values here, just it is it will be printed. So we will print counts. So counts will have a printing function will do after it, and the counts also will be go to output. So it's like a forking here. Here is the end of this pipeline, and it will goes into two ways. One of them is to be printed, and the other is to be formatted and to be written. So let's check it like now, save it and go and run it again. Now you can see that some of these values has happened just once, and other having more than one, like this, like camp and for. So you can check the output by just printing it, but this work only locally because globally you cannot access the console in which is or the shell in which the printing is done. So if you are running it over the cloud, you cannot see what is printed. Just you can uh, see the output stored in a file, but you cannot see the printing output. So this is good technique if you want to debug your code locally. So now let's delete it and let's add some functions. Here, if you can see that the word is counted, but it is case sensitive, which means that if there is king with lowercase k and king with uppercase k, both of them will be counted as different words. So what I want to do now is to add a new job, uh, append a new job, let's call it lower. And for this job, it'll take each word, not line, it'll take a word. So let's delete this right here and start by uh, doing a new pipeline. Let's call it words, and it takes the output of lines, and after this apply to it uh, a job called lower, and for lower it will be one to one. Before one to one, and let's split the line first. So I'll take this as a copy and paste it right here, and then add a new job like a lower. And for lower, I'll do for each word convert it into lowercase by using beam dot map and do a nameless function that takes each word and run lower on it, which is convert it to lowercase and return this. Now, after the word is converted to lowercase, we can repeat whatever we want, like doing this. And here the word will be counted as without taking into account the case of each character there. So let's check this first. I didn't run it yet, but I didn't run it before. So if I go to the previous output, like where is it? It's called output, and it is here in its output 0, 1. You can see that there is king and there is another king. There are both are interpreted as different words because they have um, different uppercase lowercase combination. So if I run this new code, which is word count 2, this won't be happen. They will be combined together into just a lowercase king. So let's return here back and uh, let's check that I saved this before and run it again. Let's open it. Oh, there's something wrong here. So let's return and try to find what is the problem. We have to oh yeah, it's here words not lines. So we need to take words and feed it to the next pipeline. Let's return and run it back, run it again. Now it is correct. All the words are in lowercase, and the king is uh, summing of both of the two lower and uppercase, so it is okay. We can also do another operation like doing a filter. That is the name, whatever you want to name it. It doesn't matter. What does matter is the function. Within Beam, there is a function called filter, and it filters each uh, element by passing it or preventing it to pass, delete it from the list according to a condition. And this condition will be given by a nameless function, and this function will take an input x and it check if it has to pass or to be prevented from passing. So just there is a condition here, and this condition may be true or false. If it is true, this element will continue to pass to the next step. If it is false, it will be blocked here. So let's do this according to the first letter in the word. So if the first letter is between A and like F, it can pass. So just we are interested in words starting with A, B, C, D, E, F, not other words. And after this will be paired with one, and after this it will be summed and printing and whatever we want. So just if we run this, the new one, and open outputs, our new output, will see that all the words are starting with A or B or C or D or E of F, no more. So that is what is called filter. What we can do else, um, we can take the same output and fork it. So the risk counts will go in this pipeline, and also counts can go into another pipeline like this. Let's write it like here. So maybe I'll do a new one and call it count2. That will take words, not count, sorry, will take word and just take the first char of that word. We don't need to find the frequent occurrence of each word, just we wanted to calculate how many words start with A, how many words start with B, how many words start with C. So instead of taking the whole word, just what I need is not filtering, it's mapping, which take a word and return only the first char in this word. And after this char will be mapped with 1, and it will be summed to find the number of times a word starting with this chart is being written, and we can convert it into count 2, and let's say output 2 into a new into the same format, and write it to a next file, to another file, sorry. Okay, that is okay, but we have two problems. The first problem is we cannot have two jobs with the same name. So we have to change it to another, or adding two to it, whatever. But you cannot have pair with one and pair with the same name. We have to make them with different identifier, also for format, for writing, whatever you want. This is the first problem. The second problem, there is no output 2 here. So just we need to add, we added it before. So just we need to add a new argument and let it record, must be written, and its destination will be output 2, and this destination will be used to save the next file. So just we are forking here into two pipelines, and each of them are saving the result in a different file. So if it works, let's return back to here and run it again. But now if you run, we get an error because you have said that it must be output 2. It must be. So just go there and add a new argument which is called output 2, and maybe like what we can call it, like HR histogram or something like this, whatever the name you want. And when it's finished, go to the terminal and to the editor, and within your editor you find chart histogram, and here is the result. Each chart given with its with the count of the words that start with this chart. Finally, let's go and run this over the cloud. All of this are running locally. So let's run it over the cloud. So to run it over the cloud, what we need is just the project and the bucket and do whatever we want. So let's go here and you can do the same. Have the project name and put it into a variable like project, the project ID, and put it into a variable like project, and the bucket ID, and do it put it inside a variable called bucket, and do whatever we want. But we can do this in a better automatic way. There is a command called gcloud, and for gcloud there is config list projects or list project, and they give you like a list of the projects here, and just we are need the value of core, and without core we will need the value of project. So we can add a new argument which is format, and the format will be value of core dot project, like here. Okay, and this will be hyphen hyphen like this, and it give you this value, only this value, and we can take this and put it inside the project. So inside the project we will put, let's write it like uppercase one, all uppercase characters, so like dollar sign of this. Okay, what happened here? What happened is just that we are fill this variable automatically with the project name, like this. It is filled automatically. So just run this code, and this command is found inside the repo. So just this, and if you remember the bucket address is gs column slash slash, then project name, project ID, then gs. So you don't need to write this, just as a variable, put the variable here, and it will be replaced with the value of this variable. So we can run this, which is the bucket, and echo it. So we can do this like this, like, and run it. So here is automatically the bucket name is generated following this pattern, and then we can run it like um, um, let's take this for now. So for now, just we will run word count 2, and for word count 2 it will run in North America Northeast 2 and within data runner over our project, and this is a temporary location, and we have two output and output 2, and both of them will be inside of our buckets, and also the experiment will be unsupported Python version. Now write it. And if you run it, go back to your Dataflow jobs, and within Dataflow jobs, you will see the forking. Here is the read. Still, it will take time to start, but let's start to understand what is happening. Here is read, here is split lower. Those three of them are described like here. There is read, split lower, this three, and the output of this, which is words, will goes into two pipelines. So there is a fork here, and the first will go to filtering pair with one, group and sum, which is here filtering pair with one, group, group and sum, and the output of this pipeline, which is count, will goes to format, and the output will goes to write. So the output will goes to format, and the next will go to write. And for the next path, you find that word goes to first char, pair with 1, 2, group and sum, and the output will be fed into format 2, write 2, which is this path. So what we are describing is pipeline, and this pipeline will be executed in minutes, and we can see the output of it. Also, we can provide it with input. If you remember, there is um, an input argument, and has a default of like King Lear in within this path. And because we didn't provide an input, it takes the default one. So let's go to this path. I'll work and return back to this to see what happened. So let's go to this path, like going here, open a new one, and gsutil list this path, and you can see there are maybe all Shakespeare's books like Winter's Tale. So we can run our code again, whatever we want, whatever the word count to example over this input. And to do this, you just need to provide it with a new argument with input and give it the path of the file, which is JS Dataflow symbols and Shakespeare Winter's Tale .text. So if you run this, this will run uh, over a new input file. Just you need to provide this argument, and if you didn't, it will follow the default input file. So now we are waiting for the data flow to run. It still takes time, or it's finished. I don't know. Let's check. This is an old one, so let's close this and return here. That is our new one. We're starting it to finish, and then we are waiting it to start and to finish, and until this we can go to our bucket, which is cloud storage, and open this, and here is result, and there is outputs, but as you can see, we have two outputs and outputs 2. So for outputs 2, we'll have the value of how many words starting with given shards is written within Winter's Tale or within King Lear. It was King Lear when we run it before. So let's refresh and wait for the jobs. When these jobs are run and working and finished, um, you will see that there are a new files will be created here containing our data. And here is the first example of um, data flow and how it is applied to word count with some um, it changes from us to the default one given by the data flow library. So start waiting it to start and run. Start it's the first stage is completed here, so it started and the stage completed and the stage completed. Go on. Now it is in the writing phase and it finished. So go here and do the refresh. And here is output and output 2, and as you can see output. Okay, I can see it right here. So let's go to the console and copy the path and just um, go and gsutl lsgs colon / and paste. Not ls, sorry, it's cat. Concatenate or cat, which is displayed on the display. So here is the values, the word and the count for each of them after converted to lowercase. If we did the same but for outputs 2, it will be like this, which is each char with the value here. Okay, now I hope you get familiar with what is Dataflow, how we are writing Apache Beam for it, and how to run it locally and how to run it over the cloud. See you in the next video. Bye bye.